All right, now that we had a refresher on what inequalities are, we're actually going to go to, we're going to move to solving an inequality. And remember, when we're solving anything, what we're doing is we're trying to find the answer that would make a statement true. So when I'm trying to solve this inequality, I'm trying to find all the values. Now when we move to inequalities, we just learned that there's a range of answers. There's not going to be just one answer. There's a range of answers. So when I solve an inequality with one variable, I'm trying to find all the values of x that would make this inequality true. The steps in order to do that are listed right here. The first thing you have to do is find your boundary point. And then you have to decide if that boundary point should be included. And then you have to decide which side of the boundary point all the solutions lie on. Okay? So the very first step, finding the boundary point, is really about finding the value that actually would make this side equal to this side. So what we do is we change this into an equation. So I'm going to just rewrite this, but as an equation. And we know how to solve equations. Now we're just solving for x. So we're going to add 2x to both sides. I get 3 is equal to 1 plus 2x. Subtract 1. I get 2 is equal to 2x. Divide by 2. So x is equal to 1. So what I just found out is that that's the boundary. And from that point, that's the point that on either on everything above 1 is going to make the inequality true, or everything below 1 is going to make the inequality true, because 1 is where this side is equal to this side. Okay? So I'm going to start by showing this graphically. And I do a little number line. I don't have to make it elaborate. I actually only have to put 3 numbers on it. I'm going to put my boundary on it. And then, because this is my boundary, either it's going to be all the numbers above 1 and all the numbers below 1. So all I have to do is really put one number that's above 1, which is 2, and one number that's below 1, which was 0. Okay? So I've done my first part. I've found the boundary point. Okay? So the next step is to decide if that boundary point is included. The thing that helps us to decide that is this sign right here. If it is a less than sign or a greater than sign, that means that that boundary point is not included. And in this case, 1 would not be a solution to this inequality because it doesn't have an equal sign underneath it. So if I see that my inequality is either a less than or equals a less than sign or a greater than sign, what my boundary point, the way I'm going to show that on my number line with an open circle, because that says don't include that. If I had a less than or equal sign or a greater than an equal sign, that means I would include that boundary. If this had an equal sign underneath it, 1 would be a solution to that inequality. And I would show that on my number line by filling in the circle, which means include that point too. That point is also included. So deciding if the boundary point is included is all about this sign right here. Okay? It's about that symbol. And because it's a less than sign, I'm going to put an open circle right on 1, where 1 is on that number line. Okay? So the third part is to decide now, well, which side of this boundary is all of my solutions? And the best way to do that is to plug these numbers into the 0 and the 2 into the inequality and find out which one makes it true. Because if 0 makes that true, then all the numbers below 1 are going to make the inequality true. Or if 2 makes that inequality true, then all the numbers that are above 1 would make the inequality true. So I'm going to start by plugging in 0, because 0 is the easiest one, and I'm going to plug it into the inequality and see if it makes it true. So 3 minus 2 times 0. And I really am questioning this. Is that less than 1? Well, 3 minus 2 times 0 is 0, so 3 minus 0 is 3. Is 3 less than 1? No, it is not. So that means that the numbers that should be working, the numbers that are solutions to this inequality, are all the numbers that are actually greater than 1. Now, the way I show that is I would shade everything above 1. So this is a graphical representation of all the values of x that would make that true. Now that seems counterintuitive because I have this less than sign, so you kind of assume that it would be everything below. That's why we really want to do this, because we can't always go with instinct. Now, I like to check just to make sure, so I would plug in a 2 into that inequality and just make sure that it really does make that statement true. And I plug in 3 minus 2 times 2. Is that really less than 1? Well, 2 times 2 is 4, and 3 minus 4 is negative 1. Is negative 1 less than 1? Yes, it is. So I did. So we did find the solutions to this inequality. So I have represented it graphically. So this is one way to represent it. But I also would like you to represent this as an inequality. So and writing out the inequality, all the values of x that make this true are all the x's that are greater than 1. That's what this graph shows. And that's what we just proved. Like when I plugged in a 2, that made that true. Okay? So you're going to be asked to do 2 more problems. Make sure that you are showing the solutions to your inequalities in 2 ways, that you show it graphically as well as in an inequality. Okay? Go to it.